Hi guys, welcome to week 6 of Introduction to Programming course. I hope you guys are enjoying this course. I hope you are understanding all the concepts we have discussed up till now. If you have any difficulties, you can always join me in my office hours, or you can drop me an email and we can arrange a session for you guys. But I can see that even during the lab hours, even during the assignments, you guys have done an excellent job. Most of you guys, I can see that you are grasping the concepts. I'm sure if you are having difficulties, you can always discuss with me. You can talk to your colleagues as well. There is a lot of stuff is available online, so you can always go online and grab some exercises that you want to do on some concepts that we have discussed in our previous weeks. You can always go through your textbook. There are several exercises available at the end of all the chapters. You can grab those exercises, start to do them, complete those exercises. I mean, in programming, there is a saying that there is no right way of doing things. There can be multiple right ways of writing a code. So not necessarily every way of writing a code is good or bad. So it's absolutely fine if something I'm telling you, I'm programming something and you find another way to program the same code, same program, same software. It's absolutely fine. It's absolutely fine to do that. As long as it's making sense to you, it's absolutely fine to do that. So we have gone through 2 lab exercises up till now. So this week we are going to have another lab exercise 3, as shown over here. And next week shows lab exercise 4, but we are not going to have lab exercise 4 next week. We are going to put that somewhere in week 9. Just want to give you guys some break from these lab exercises as well. So maybe we'll have lab exercise number 4 in week number 9 or maybe week number 10. So this week we are going to have a lab exercise, which is lab exercise 3, and then we are going to take a break from lab exercises for a couple of weeks. And then last lab exercise we'll do somewhere week 9 or 10 or maybe 11, right? So that's it. I have received all the assignments from all the students. In fact, majority of them I have received them, and I'll be marking them soon. Hopefully you will get your marks up by the end of this week, if not at the start of next week. So go through your marks. If you have any difficulties, if you think you deserve more marks, please get back to me, discuss with me. We can always discuss, no worries at all. 1 or 2 students, they already asked me about the feedback on their lab exercise, which is very good. I really like that. It's always a good idea to ask that. If you are losing even 0.5 marks, you need to get back to me and ask me where I lost marks, so that you don't make such mistakes in future, right? So it's always a good idea to get feedback on your assessments. I do have all your assignments or your labs marked with me, so if you are looking for feedback, you can ask me and I can send them back to you, so that you can have a look on them. So it's absolutely fine to ask, no worries. So today we're going to talk about recursion. It's a very important concept in programming languages, and it helps you optimize your code a lot. So we're going to talk about that in a while. But before we actually go there, just wanted to again tell you that there is going to be another assignment that might be in week number 8 or maybe in week number 9. So we might have another assignment, but that is not now. You still have enough time. Take a breathe. I know you guys are taking multiple courses and you are having a lot of work already, so I don't want to burden you guys with more stuff. I just want to make sure that you guys are learning from this course. This is the most important thing for me, and I hope that if you have any problems, you just go online, search for stuff online. If you don't find any help, just get back to me, and I'll try to make you understand that concept again. So the only problem with the online learning is you cannot communicate in real time with students. This is the only problem. So if you are having some problems, some questions when you are going through the video, please write them down and you can ask them later on, because then what happens is you think of a question when I'm teaching something, and then you forget to ask questions and it will remain a question. uh, which is not a good idea. It's always a good idea to clear up all your concepts. It's very important to clear the concept, because as you can see that we are building foundations for all these things, and every week is connected to the previous week, so there is no disconnect between the weeks. So it's important you know all the concepts properly. And this course, as I always say, is one of the most important courses in your degrees, because this is going to set foundation for everything. All the important courses are going to be based on this, because computers are all about programs. It's all about programs, right? So if you don't know how to write a program, if you don't know the meaning of the code behind it, then it becomes very difficult to understand the coming concepts. So make sure that you clear up all your concepts, make sure you understand all the concepts properly, and from here on you can build a strong foundation, right? So having said that, I just want to quickly show you this breakdown again. So we have done 2 of the lab exercises, we have done 1 of the assignments. So we are halfway around this assignment mark, and we are almost halfway around these lab exercises as well. So I expect all of you guys, as I always say, to get maximum marks over here, all of these assessments. This is going to help you a lot, going with a very positive mind in the final exam. So please make sure you work hard on these things, at least these 2 things, because you have already done few of them and you know how to do them. Project is the only thing that is we have no idea right about the project right now. We're going to talk about that in future, but at least you know how the assignments are going to look like, you know what lab exercises are, how they're going to look like. So you can practice before these lab exercise, at least do some practice before the assignment. I don't mind you guys going online when I give you assignments, finding help from there, but don't copy paste the code from there. I don't expect you guys to do that. You can definitely learn from going online how things are done, but do it in your own way. This is what I need, because as I said that you might get code from somewhere here and there, you might pass this course, but this is going to create a lot of problem in coming courses, because if you don't understand the concepts, then it will be very difficult in coming 2-3 years. So make sure you understand the code you are getting and then doing it yourself. In lab exercise, last time I have seen a lot of students getting the code from internet, not even changing the name of the variables, not even changing the logic behind it. So it's not gonna work. You're gonna lose marks. And when you do Google, I know the lab exercise is only for 1 hour, so you're gonna pick up first 2-3 links for that code, and I can see that all of you who have copied from internet have copied from the same source, and it's the whole agenda, whole aim behind teaching you this, it's gonna die if we do something like that. So please don't take code from internet. If you are taking help from internet, it's absolutely fine to do that, but then make sure you understand that, because when we went to breakout session and I asked questions about the code, you had no idea. And I mean, I'm not talking about all the students, students who have taken the code from internet and they had no idea what this code is doing. So make sure you understand what you are doing. And yeah, that's pretty much it for this. Let's quickly move to our topic now, which is called recursion. So before actually going to recursion, what I'm gonna do is I'm gonna write a code for you, very simple code without recursion, right? So I'm gonna do that, and then we're gonna dive into what recursion is and why we are doing recursion, right? So let's first understand what recursion is, and then we are going to see what we are going to do with our programs using recursion and how it's going to help us, right? So let's do that. I'm going to write a program that is for calculating the power for a number, right? So for example, 2 raised to power 2 is 4, 2 raised to power 3 is 8, 3 raised to power 2 is 9. So we are going to create a program. We will take, so they are called base and exponents, right? I'm sure you already know about that. So base is, if we are calculating 2 raised to power 3, then base is 2 and exponent is 3. So we are going to take 2 inputs from the user, a value of a base and a value of an exponent, and our program is going to calculate the power for us. right? Calculate the result for us. Let's do how we can let's see how we can do that. Let's include all the necessary libraries. I'm going to include only one for this because I don't believe I need any other libraries. Oops. Okay, so I'm gonna bring all the namespace like this. Since you are writing a very small code, it's always a good idea to do something like that. But if you want to include very specific information from this namespace, it's absolutely fine, and that is actually the best practice. But since it's a very small program, I'm not bothered doing that. So what we want to do is we want to take two numbers from the user. I'm going to take a base number and an exponent from the user. So I'm going to ask user enter the base value, and I'm going to take a cin from the user. So I'll take a base value from the user, and I'm going to take an exponent value from the user as well. So enter the exponent value, and I'm going to call it exponent, and yeah, so I have taken two inputs from the user, and I'm going to use functions. It's always a good idea to use functions. Last time we have used functions in our lab exercises, and even last week was spent working on functions. So we are going to work on functions from now on. Almost in all of the programs we're going to write, we are going to use functions, right? So let's write a function. I can call it anything, maybe a power function, since it's going to calculate the power. So this function is going to return me the result of the power value. For example, if I do 2 as a base, if I get 2 as a base and 3 as exponent, then I'm going to pass these two values to this function, and this function is going to return me 8, because 2 raised to power 3 is equal to 8. Since it's going to return me something which is an integer, in this case I'm going to call it int power, right? And I'm going to take again same variables over here, int exponent. Can take any value here, any name here. Since I'm going to pass these two values to the function, to this function, I'm going to do it this way. So how to do that? What happens normally is, whenever you are calculating the power of a function, you are multiplying that number. So if I have 2 here and if I have 3 here, basically what I'm getting is, let me just do it over here just to tell you. So what we do is, if I have 2 raised to power 3, what is happening over here is I am multiplying 2 by itself 3 times, right? So if I take 2 to the power 4, I'm actually multiplying this number that many times to itself, right? So I'm going to do 2 into 2 into 2 into 2, right? Similarly, if I do 3 raised to power 2, I'm multiplying this number that many times to itself. So this is what I'm doing. So 3 into 3, right? So this is what basically exponential function normally does, right? So we're going to do something like that. So if you see the logic of this function, I'm going to run a loop, right? I'm going to run a simple loop that is going to multiply the number, multiply this number to itself this many times, right? And this is what the logic is. And I'm going to store that result in something and then return that result, right? So let's take a variable return int result, and I'm going to start it with 1. Let me do this, and then I will tell you what to do. So I'm going to run a loop. I'm running a for loop. You can run a while loop if you want. So int I will start from 1. I will tell you why not to start from 0, but you might already know why not to start from 0. So less than exponent I plus plus, right? And what we are going to do is we are going to return this result, right? We are going to return this result because inside this loop it will calculate the result, and then once we are done with the calculation, we are just going to return this result, right? So what I'm going to do over here is I'm going to multiply this number, base number, to itself, and I'm going to store that result over here, right? So what I want to do is I want to multiply base by itself and gonna store that result into result, right? So okay, so what happens now? Let's see. So let's assume result is 0. Let's assume result is 0. So and we have this thing I is running over here, and it will run So let's assume we have taken base 2 and exponent 3. So this is 3 and base is 2. So I will start from 1 this time. Why I am starting it with 1? Because if I start it from 0 and I have 3 over here, it's gonna run 4 times, right? 0, 1, 2, 3. It will run 4 times, right? So I'm gonna start it with 1 so that it runs 3 times. So it will be 1, 2 and 3. It will run 3 times. You can program it any way you like, but this looks more readable to me, so that's why I'm doing it this way. But you can always start it from 0 and make it less than exponent. You can do that as well, no worries. Okay, so we have result is equal to 0 and we are multiplying 2 by 2, assuming we have 2 in the base. So 2 multiplied by 2 is 4. So we have 4 in the result, and i's value was 1, right? Then once we are done, i's value will be incremented, so I will be 2 now. 2 is less than 3. Yes, it's less than 3. So we'll come over here. We are going to multiply 2 by 2, 2 with 2, and it will generate 4 again. It will store in result, right? Now every time I run this loop, this is going to be 4 only. It will always return me 4 because I'm just multiplying 2 with 2, right? And this is not how it's going to solve our problem. What we can do is we can store the result in a variable like result, and result is going to contain that value, right? If I use that value and multiply that value with the next iteration of this value, it's going to result me something different. So if I change this base to result, let's see what will happen. So we have 0 over here. We have 1 over here. Exponent value, let's assume, is 3 and this is 2 again. So what we can do over here now is we can let's debug this. So we have I, first iteration, I is 1. 1 is less than 3. Yes, it is less than 3. So it will go inside. It will multiply result with the base, right? So result is what? Result is 0. 0 multiplied by 2 will be 0. So result will be stored in result, right? This result will be stored in result variable. Okay, so the next iteration, I will be incremented. So I will become 2 now. 2 is less than 3. Yes, it is less than 3. Now what will happen is it will store the value of this result in result again. So what is the previous value of result? 0. Remember, 0 multiplied by 2 was 0. So 0 multiplied by 2 again will result in 0. So this will always return me 0 all the time, because the value of result will be 0. Anything multiplied by 0 will be 0, right? But anything multiplied by 1 will be that number, right? Will be that number. So if I change this result from 0 to 1 and try to run this again, let's see what happens now. So again, at the first iteration, I is 1. I is less than 3. So 1 is less than 3. Yes, it is less than 3. It will go inside. So 1 multiplied by 2 is 2. So result now contains for us 2. Let me write over here. So result now contains for us 2, right? Now if we will, and I contains for us, it contained for us 1. Now next iteration, I became plus plus, so I became 2. 2 is less than exponent, which is 3. Yes, it is. So it will go inside. So what will happen is result, what was the previous value of result? It was 2. 2 multiplied by 2, assuming that base value was 2. 2 multiplied by 2 is 4. So result will become 4 now. And now the value of result is changing, which is good. In previous two cases it was not changing because of 0, and then before that we were having base multiplied by base. It was giving us the same result every time. So first the value of result was 1. Now the value of result, then value of result became 2. Now the value of result becomes 4, which is good. Now I is 2. All right. So I is incremented. I incremented. We have 3 over here. 3 is less than or equal to 3. Yes, it is, right? Because it's not, 3 is not less than 3, but 3 is equal to 3, which is good. So we can go inside this loop. So result will be multiplied by base again. What was the value of result? Previous value of result 4. 4 multiplied by 2 is 8. So we have 8 here, right? We got 8 over here. Now the value of I will be incremented again. So value of I will become 4 now. 4 is less than 3? No. 4 is equal to 3? No. So it will come out of this loop because this condition is now false. It will come out of this loop and it will return this value. So we had two to the power of 3. So 2 to the power of 3, and we got our result 8. This is exactly what we were looking for, right? And it will return us the result of this whole function. Very, very simple. You can debug it using any other number. Do it by base 2 and 4, or do it by 4 by 4. It will work fine, right? So we have created a program that can take the power of a number from the user along with the number and then pass it to a function, and that function returns us the result of that power number, right? So we just have to now call this function and pass the value. So what I'm going to do is I'm going to say, and I'm going to show a result. So result of I'll do something like this: result of base value to the power of, maybe something like this. You can make it look any way you like, exponent, and I'm gonna do something like this maybe, and then show the result. So I'm gonna call the function, I'm gonna pass it two values, base and exponent, and put a semicolon. Let's end L also and put a semicolon over here. Let's see what's going on now. So let's pass the base value, which is 2. Let's pass the exponent value, which is 3. Result of 2 to the power of 3 is 8. That's good. That's what we were looking for. So 4 to the power of 3, maybe 64. Excellent. That's exactly what we were looking for. So 2 to the power of 4 maybe is 16. That's exactly what we were looking for, right? So that's what we were looking for. So this is how you do a power function. What I want to do now is I'm going to write another function for you, but I'm going to save this function first. I'm going to put this in Notepad for now. I'm not saving it. So I'll put this in here. I am going to write a factorial function, right? Why I'm doing this is I'm going to tell you a better and efficient way of writing this code, right? For power function, for factorial as well, right? So let's see first what factorial is. I'm sure you guys already know what a factorial is, but let me quickly revise it for you. So if I do a factorial of 3, this is what a factorial of 3 looks like, right? So it means that I have to multiply 3, I have to multiply it with all the previous numbers. So 3, then 2, then 1, right? Similarly, if I do 4 factorial, I have to multiply 4 with all the previous numbers. So I will do a 4, I will do a 3, I will do a 2, I will do a 1, right? So this is going to result in 6, this is going to result in 24. Similarly, if I do 5 factorial, same thing. So I will multiply 5 with 4, with 3, with 2, and with 1, and it's gonna return me 120. Yeah, so this is what it is going to return, right? So this is how your factorial looks like. So if I want to generalize this, what I can do is I can write something like this, considering n is some number, n factorial will be something like this. N factorial will be n multiplied by n minus 1, n minus 2, and up till 1, right? Now let's replace this with 5 now. So I'm going to do 5 factorial. So 5 multiplied by 5 minus 1, multiplied by 5 minus 2, multiplied by 5 minus 3, multiplied by 5 minus 4, which is 1, right? We don't multiply by 0. If you multiply it by 0, then everything will become 0, right? So we don't want that. So 5 multiplied by 4 multiplied by 5 minus 3, 2 is 3, multiplied by 2, multiplied by 1, which will give us 120. So basically this is the general formula of n factorial, right? So this is how we do it. I hope you guys know this, and I'm going to move further, write a program now, and then we are going to see how we can improve this, function. So let's go back to Visual Studio and let's try to write this program. I'm going to keep sum of this. Let me remove this at least, the function. And what I want to do is I'm gonna remove this line. I'm gonna take a number from the user. So I'm gonna take a number from the user, and my program will calculate the factorial for that, right? So I will ask enter the number. I'll ask enter a number, and then take that number from the user. So take that number from the user, and then I will create a function and pass this number to that function, and that function will calculate the factorial for me and return the result for that, right? So let's create a function, maybe call a factorial, and I'm gonna pass it a number, right? I'm gonna pass it a number. So I will pass it a number, and again what I want to do is I want to create a variable result which can contain my result. And if you see, I removed that. Anyway, so what you do is you basically run a loop. So why you run a loop? Because you want to multiply each number by all the previous numbers, right? So we have to just run a loop, very simple. Otherwise, if you do manually, then it will run for one number, but it will not run for other numbers, because then our statements will end up. So for loop will help us in finding a number very easily, because it will be dynamic in nature. So we can run a for loop or a while loop or whatever loop you want to run to a certain number and keep on multiplying that number with the previous number, right? So I'm going to do same thing. So for int I is equal to 1. In fact, I have to go backwards. So what I will do is I will take a number, I will multiply that number with each of the previous numbers. So what I'm gonna do is I will create int I will make it equal to number. So if I have a 5 over here, I will make I is equal to 5. I will make sure that I is always greater than 1, because if I becomes 0, then everything becomes 0, right? Remember, if I multiply the result with 0, then everything becomes 0. So I don't want I to go to 0. So in fact, I have to make it 1, right? So I have to make it 1 so that it multiplies. You can make it equal to 1 as well. So whatever way you want to program it, it's absolutely fine. I want to do it this way, you want to do it some other way, it's absolutely fine. So let me see what I have, and I will do an I minus minus, right? So every time we are doing a plus plus, you want to do it in a plus plus manner, it's absolutely fine, but I want to show you how naturally the process looks like. So this is how naturally the process looks like, right? So we have a number, we decrement that number. So 5 multiply by 5 minus 4, multiply by 5 minus 3, multiply by 5 minus 2, and so on. So we are basically decrementing in the logic, right? So let's program our code in such a way that the logic remains similar, right? But you want to program it any other way, it's absolutely fine, you can do that, right? So, and I'm gonna multiply this number. So I'm gonna save this result in I'm gonna save this into results variable. So what I want to do is, if I want to multiply a number with itself, it's gonna give me same results, right? It's gonna give me same result as our previous one, right? So if I start this with 1, if I multiply, for example, we have a 5 over here, 5 into 5 is 25, it's gonna always return me 25, right? I don't want that. So at least I have to change this, right? I have to change this to result, so I can multiply it with the previous result which was stored in the result variable, and then I am going to multiply it with number. So number will never change, right? Number will never change. In our power function, number or the base was never changing. We were multiplying that number with itself again and again. But now we don't have to multiply a number with itself. We have to multiply that number with its previous number, right? Previous number. And how to get a previous number? I is giving us the previous number, right? I starts with the number, then it decrements, so it's giving us the previous number, then it decrements again, give us the previous number. So I can replace number with I, right? I can replace it with I. let's see how it looks like, and I'm going to return result, right? So this is just going to be very simple. So let's debug this. So I have I is equal to number. Let's assume we have 5 here. Let's do it 3. 5 will be too much. So let's do it 3. We have number, assuming number is equal to 3. Let's see result. Result is starting from 1. We are not starting with it with 0, because if I multiply 0 with something, it becomes 0, right? So I don't want to start it with 0. I want to start it with number, with 1, right? So we have these things. So I is equal to number. So I made I is equal to number. So I has 3, number has 3. I is greater than 1, 3 is greater than 1. Yes, it is greater than 1, right? So it will go inside. So result is what? Result is 1. So 1 multiplied by 3, right? 1 multiplied by 3. I is 3. 1 multiplied by 3 is 3. So result will now contain 3 for us, right? Okay. Then it will decrement. I will decrement. So I will become now 2. And it will check 2 is greater than 1. Yes, 2 is greater than 1. So it will go down. It will multiply the previous value of result. Previous value of result was 3 with the new value of I. New value of I is 2, right? 3 multiplied by 2 is 6. So result will contain 6 for us. Then it will decrement I. So I will become 1. I will become 1. I is greater than 1. 1 is greater than 1. No, it's not greater than 1, right? 1 is not greater than 1. So it will come out of this loop. It will come out of this loop and it will return the result. So which was 6 in our case. So it will return 6, and factorial of 3 is 6, right? Similarly, you can run it for other numbers like 4 and 5 and you will get the same result. So now we have created a method or a function that takes a number as a parameter, calculates the factorial of that number and return us the result of that factorial, right? So I'm just gonna call this function now. So I'm gonna say factorial of 5 or whatever number I'm gonna pass is, I'm gonna call this function factorial. I'm gonna pass a number to it, and number is the one that is given by the user, and do an ender here as well. So let's see. So enter a number, enter 3. Factorial of 3 is 6. That perfect. 4 factorial of 4 is 24. 5 is 120, I think. Factorial of 5 is 120. Perfect. So this is running absolutely fine for us. Absolutely fine for us, right? This is exactly what we were looking for. So I hope it is making sense to you. It's not a very lengthy or very complex function, but a very, very simple one. And it can perform a lot of things for us, right? So we can find, it's very, very easy now. You can put it any number and find a factorial, right? So I'm going to copy paste this one as well in a separate file, and I'm going to use it later on. So this is this. Let me put a star here just to know that they are two different functions. Okay, so this is what we have now. We do know that we have two different functions. So let me run these slides as well. So I have written something like this for you, and I have written something like this for you as well, which happen to be very similar code, which is good. Okay, so what we want to do is we want to learn about recursion today. First, let's understand what a recursion is, and then we will come back to these functions again, these programs again. So recursion is a function that will call itself. Very simple. So recursion is a function. So for example, I've created a function add, right? It will keep on calling itself. So if I have maybe int add something like this, and I have a function body. If a function is calling itself inside its body, this function is called a recursive function. Very, very simple definition. Very simple definition. If inside a function we are calling this function itself, we call this function a recursive function. Similarly, in our main function, we have never done that, but we can do that. In our main function, if we call main again, this will be called a recursive function because the function is calling itself again and again, right? So whenever a function calls itself again, it will start from the beginning of that function. So if we have, for example, 3 statements in this function, and I call this function itself, the function will again start from instruction number 1, then 2, and then 3, like this. So a function that calls itself is called a recursive function. Now function can call itself directly or indirectly, right? For example, we have a function a that calls a function b, and that b function then calls a function a again. It means this is also recursion because a is calling itself through b. This is an indirect recursion, but it is still calling itself, right? So this is also a type of recursion. So if a function calls itself through another function, then it's called a recursive function as well. So maybe we have a function a. Inside this function, it calls a function b, and in the definition of function b, we have a call for function a, right? So this is called an indirect recursion. When a function is calling itself, a is calling itself through function b, right? So this is also called recursive function. What happens in recursive function is it makes copies of itself. So if function a add is calling itself, it's basically creating a copy of it, right? It's creating a copy of it, and it's starting from the beginning again, right? So if this function is run 2 times, so there was a main function call add function, and add function call itself inside. So what happens is first call is to the add function from the main method, then the second call to the add function is through itself, right? Through itself. So function is calling itself from within itself. So what is happening is it's just making another copy of itself, right? This is what is happening, and it is going to make a lot of sense to you when we are going to write a program, right? So this is what recursion is. What it does is it will just make sure that your program becomes simpler. So if a function is calling itself again and again, it will make your code optimized, so you don't have to write hundreds of lines of code to do the same thing again and again. You can call a function itself and it will do the work for you, right? And you're gonna see how it's gonna make sense to us. Let's talk about factorial using recursion. What is happening over here is we are multiplying a number with the previous number, and we are multiplying a number with the previous number, and we are multiplying the number with the previous number. So we are doing same thing again and again and again, right? We are just taking a number, subtracting 1 from it, and then subtracting 2 from it, then subtracting 3 from it, until it becomes 1, and we are just multiplying all of them. So you can see that we are actually doing same action again and again. So we are subtracting something, and then we are multiplying it, right? And we are doing this again and again. Then we are subtracting, then we are multiplying, then we are subtracting, then we are multiplying. So this is basically a good example of a recursion, right? Although we have solved it without recursion, without calling the function itself, but it can be an excellent example of learning what recursion is. We can call a function to itself, and then it will perform the same thing for us again and again and again, right? And that's what we're going to do today. So what I'm going to do is I'm going to write a recursive function for factorial for you, and then we are going to debug that to see how it works, right? What it does. So let's do that together. So I will keep it like this, and I will keep it like this. I'm just going to change something inside because I'm going to write the same function for factorial, right? So what happens in factorial is, first of all, in a factorial we need to have a break condition, right? Break condition. Going back to our slides again, in order to have a recursion function, so if we are doing, as I said, if we are subtracting something and then multiplying something, and we are doing this again and again and again and again, then it will keep doing that, right? We need to have some break statement, right? We need to have a break statement so that this actually breaks. This, it's inside a loop, right? It will keep on calling itself. But that should break somewhere, otherwise we are stuck in an infinite loop. So if you see this formula of factorial, where does it break? It breaks at 1. When a number becomes 1, it will not subtract it anymore, right? This is what is happening in the formula. So if a number becomes 1 after subtracting, if a number becomes 1, this loop will not go again and do the same thing. It will just stop here, multiply this and stop here, and then calculate the result for us. This is what is happening. So 1 can be a breaking statement for us. So what we're going to do is, we'll see when we reach 1. So we'll run a condition. So what we are going to do is, I'm going to keep this same. We are going to take a number from the user and send this number to the function, and function will call, function will do some computation and return us the result of that number as a factorial, right? So as I said, we need to first have a break statement, and we don't have to use loop inside this specific function because function itself is going to call itself, so we don't need a loop, right? So first thing, if you see over here, previously we had a loop here, which was running to each number and subtracting it from itself, then multiplying that result to itself. Basically this is a loop, right? Now we don't want that, we don't want to do that. We will create this function in such a way that it will keep calling itself, it will call it itself, and then it will return the result. That's what is going to happen, right? So what I want to do is, first of all, in almost all the recursive function, you need to write a break statement. Because if you don't have a break statement and your function doesn't know where to stop, then you are stuck in an infinite loop. And where are we going to stop? We are going to stop when the number becomes less than or equal to 1, right? We have seen this, right? If a number is less than or equal to 1, then we are going to break this, or we are going to return. So what happens is, if I do it again, factorial of 1 is 1, right? Very simple. So if it reaches to a condition where factorial is 1, then it should return 1. This is what we want, right? It should return 1, and this is going to happen somewhere, right? So what happens is, if you see, if I do 5 factorial, what it does is, basically 5 factorial means 5 into 4 factorial. This actually means something like this if we break it down. And if I further break it down, it means 5 into 4 into 3 factorial, right? If I break it further down, it will do 5 into 4 into 3 into 2 factorial, and then 5 into 4 into 3 into 2 into 1 factorial, or we can simply write it as 1, because 1 factorial is equal to 1, right? Basically this is what is happening, right? So a number is multiplied by the factorial of its previous number, then the number is multiplied by the factorial of its previous number, and so on, right? So this is what is going on. So if we are talking about 1 factorial, it's going to return us 1, and this is exactly what we need as a break statement. So if we have passed 1, so factorial of 1 will be 1, so we're going to return 1. This is the break condition for us. It's going to break over here, and this is what is going to happen ultimately. So if I do 5 factorial will do 5 into 4 factorial, and then 4 factorial will do 4 into 3 factorial, and so on, right? So what I'm going to do is, I have a break condition now. If this condition doesn't run, so for example, if I pass over here 2 factorial, this is not going to run, right? Because 2 is not less than or equal to 1. So I have to have an else statement for larger numbers that are larger than 1, right? And what I'm going to do over here is, basically what I'm doing is, I'm multiplying the number by the factorial of the number less than that, right? Something like this. Let me go back and show you that again. I just closed that. Okay. So what I said is, if I'm talking about 4 factorial, for example, 4 factorial means 4 into 3 factorial, right? Which is, if this is n, then this is what? N minus 1, right? And this is a factorial, right? Similarly, if I do 5 factorial, what I am doing actually is, I am doing 5 multiplied by 4 factorial, which means that this is n and this is n minus 1 factorial, right? Similarly, this is n into n minus 1 factorial, right? This is what I am doing. Similarly, if I do 3 factorial, it's 3 multiplied by 3 minus 1, which is 2 factorial. So this is n, this is n minus 1 factorial. I'm just multiplying these, and this is exactly what I'm doing over here in my function. I am doing number multiply by factorial of number minus 1, right? So if this is 3, I am doing 3 multiply by 2 factorial, which is number minus 1 factorial. And how do I calculate factorial? I'm just calling this function again. That's it. That's it. And since this function wants me to return something, I have to just return this. I'll just return this one, right? I'm going to debug it for you in a while, and I'm going to explain it to you once again so that you get a better idea of what is happening over here. Let's first run this code and see if it's working or not. So factorial of maybe 4, that is 24, 4, that is correct. So factorial of 3 is 6, it's 6, factorial of 5 is 120. It's working absolutely fine for us. It's working absolutely fine for us. And this is exactly what we wanted, right? This is exactly what we wanted. Now let's debug this and see what's going on. And I'm gonna make a tree for you so that you better understand what is going on. So let's assume we have number is equal to 4. Let's take it 3. And that's it. That's what we are looking for. So number is 3. 3 is, so this statement will run 3 is less than or equal to 1. No, so this statement will not work. Then we'll have else. Else means it will go here. So number 3 multiply by factorial of 2 minus 1. So it means that 3 multiply by factorial of this one. Whenever compiler sees this one, it says that okay, this is a function which is calling itself. So it will go up again and call this function again. And let's see what's going to happen. I'm going to go to my slides, and that's the reason I put this over here, because I wanted to debug with you together. So let's see what happens. So I'm going to call it f. So I'm going to call function f, right? So you can call it factorial, but just for simplicity, I'm going to call this function f. All right. So I'm going to call a factorial of, let's do it 4. I'm going to call factorial of 4. So when I'm going to call factorial of 4, it's going to see over here my number n is equal to 4. Okay, so I'm going to call number n. N is less than, number is less than or equal to 1. So 4 is less than or less than or equal to 1. No, so it will not go inside, it will come over here, right? Then it will say, it will have two statements over here: return number into factorial of number minus 1. So it will have something like this: number, which is 4, so it will have 4, and the second statement is this one, which means factorial, since I said f as a function name, f of 4 minus 1, which is 3, right? So it has something like this. Now when compiler sees something like this, it will call this factorial function again. It will call this function again. So what will happen is, it will go back again. Now this number is, so it's going to take this factorial now. So this number now is 3, because we are talking about factorial of 3 now, right? So it will go inside, and this is now 3. 3 is less than or equal to 1. No, so it will not run again. It will go to else again. It will do return number into, now nothing will be returned until we have numbers over here. If we have functions, it will keep on calling, and return will be kept quiet. So it will not return anything. It will just return something when we have a result. Right now we don't have any result, right? We are just going inside the function. So it will say return 3 into factorial. So it will say 3, which was the number, and this is what we are saying. The first statement is 3, so we have 3 over here. Then it will take factorial of 3 minus 1. So it will call the function factorial f again. In this case 3 minus 1 is 2, so it will call this function again. Now we have this one, right? Now what happens when it comes over here? It will call this function again. This time the parameter for this function is 2, right? 2. So it will go and see again. 2 is less than or equal to 1. It's not. It will not go inside. It will come to else, and it will call this again. Return number into factorial of 2 minus 1. So return number. Number is what? 2 in this case. 2 is this. and then it will do factorial of 2 minus 1. So factorial of 2 minus 1 is 1, factorial of 1, right? Now compiler will see this function again and it will call this function again, this time with the parameter 1. So it will the number now will become 1 for us. 1 is less than or equal to 1, 1 is equal to 1, yes. So it will enter here and return us 1. So this function is going to return me now 1, right? Now if you see at this level, we have numbers. So I'll multiply 2 by 1. Why? Because the function says like this. So 2 multiply by the result of this function. The result of this function is 1. So 2 multiply by 1 is 2, right? So 2 multiply by 1 is 2. So this factorial is going to return me 2 as well, right? So I have calculated this level, which was for this. So the result of this one is multiplying these two numbers. So multiplying these two numbers gave me 2. So it means that now I have result for this function, which is 2. Now at this level of the tree, I again have two numbers, right? I will multiply them again. Why? Because my function is saying multiply this with this one. I now have 6 over here, which means that I have computed this level as well. So the result of factorial of 3 will return me 6 over here, right? It will return me 6 over here. Now I am at this level. I will multiply these two numbers. Now I can multiply these with these together, because now I have both the numbers over here. I can make a computation. Previously it was a function. I cannot multiply a number with a function, right? So I have to get some results. So at this level I will multiply 4 by 6. So this level is now complete, which will give me 4 into 6, 24, which will be the result of factorial of 4. The top level, since I was looking for this one. So factorial of 4 is 24, and this is exactly what is happening. This is how we are working on this factorial function. Very, very simple. I hope it makes sense to you. That's why I'm trying to debug it as much as possible, so that you can go to the depth of each thing and then understand what's going on. All right, so try to debug it yourself. If you debug it for a couple of numbers, this will become so easy for you that you can start typing. You don't have to even see my code, and you can start typing and it will make a lot of sense to you, right? So this is how we do a factorial using recursion. Now the question is, why are we using factorial? Why do we use factorial to solve the same problem which we already solved? Now for this function, especially factorial and the other function power, I'm going to write a power function for you using recursion. The lines of code doesn't change too much. So for example, the previous code was how many lines of code? 1, 2, 3 and 4. 1, 2 and 3. So the lines of code, if you see, they have reduced for us. Number of lines of code has reduced for us, right? So this is the whole idea behind using recursion. It will optimize your code. In this case, since we never had a large function, the function itself was very small, it was still reduced to maybe some percentage, right? But normally in your real life scenarios, you will see if you have hundreds of lines of code and you start using a recursion function, it will optimize your code significantly. Imagine you are having hundreds and thousands of line of code for one of the functions. If you use a recursion for that, it will significantly reduce the lines of codes you have to write. So recursion, one of the significance of using recursion is it will optimize your code in such a way that number of lines of code will reduce. The second importance or second significance of recursion is it makes your code look nicer. It makes your code much more readable. If I give you this code, it might be a little difficult for you to understand. If I just hide this definition from you, and if I give you this code, you have to run this code to get to know, okay, what this function is doing. But if I show you this recursive function like this, you can easily understand, okay, this is a recursive call. This is a recursive call. Function is calling itself and it is doing something like this, which means that this is a factorial code, right? It makes your code much more readable, less complex and much more cleaner, right? This is what are the benefits of using recursion. So what I'm going to do now is I'm going to write the power function for you using recursion as well, and see how it can solve. It's not gonna, because again the function itself is not very lengthy, so it's not going to reduce too much, so you might not see a lot of significance of using recursion. But again, in real life scenarios, when you are going to use very heavy functions, you will see that the code has been optimized a lot. So I'm going to copy paste this code for power, and I'm going to use that to optimize, right? So I'm going to just remove all this, and let me rewrite it using recursion, right? Okay, so what is happening in power? Power is doing something very similar, very similar. What it does is, forget about this code, I just want to use this space. So 2 raised to power 3 or base to the power of exponent, what this actually does is it will multiply this number to itself that many times, right? So if I multiply it 1 times, then it's going to multiply itself this number minus 1, right? So it's going to multiply it by 2 then, right? Then it will multiply this by 1, right? So it's going to keep multiplying it by subtracting or decrementing the value of this one. So we are this is exactly what we are going to do. What we are going to do is we are going to multiply this number by itself that many times, right? And every time we are going to reduce this number, right? So for example, if I have 2 to raised to power 4, what we are going to do, we are going to multiply 2 into 2 raised to power 3. This is what is happening, right? So next time what we're going to do is we are going to have 2 into 2 into 2 raised to power 2, right? This is exactly what is happening. So 4 into 2 is 8, 8 into 2 is 16, which is 2 raised to power 4. So we are basically doing something similar to what we did for factorial. We are just multiplying it by reducing the value of this every time, right? So let's see how we can code this using our recursion. So again, we need to have a breaking statement, and if you remember, for us we are not going to multiply it by 0, because then everything will be 0, right? So what I'm going to do is I'm going to write a statement. If you remember, even in our loop we had something like this, right? Exponent is less than or equal to 1, right? So we had something like this. So I'm going to start with less than 1, and then we can make it less than or equal to 1, because 1 multiplied by 1 is 1, right? So I'm going to make it much more cleaner by saying exponent is less than 1. If it's less than 1, then return 1, right? You can make it less than or equal to 1 and see how does it behave. I'm going to make it much more cleaner. So this is my break statement. If it goes less than 1, then you just return 1, because I don't want to return 0. If I return 0, everything becomes 0. I don't want to do that, right? So I'll do something like this. And if a number is greater than that, then we have to do this else statement. And in this else statement, what I'm doing over here is basically I'm going to return, let me forget about return for now. I'm going to multiply that number with the power function of its number and exponent minus 1. This is what I'm going to do. It's pretty simple, and I'm going to return this also. Let me explain it to you again. So what is happening over here is I said that I'm going to multiply the number with the number. So let me go back. So what I was doing is basically so if it's 2 raised to power 4, I'm multiplying the number, which is base, by reducing this number by 1, right? And then I'm going to do it again, 2 into 2 raised to power 2, then again 2 into 2 into 2 into 2 raised to power 1. This is what I'm doing, right? So if this becomes, if I solve this again, it becomes 2 into 2 into 2 into 2 into 2 raised to power 0, right? This will be next progression, right? But anything power to 0 is 1, right? So This is what I'm doing. So if it's less than 0, I'm going to return 0. I'm going to return 1, right? So if it's if it's less than 1, if the power is less than 1, which less than 1 is 0, right? If it's 0, then I'm going to return 1, right? So if you want to further expand this, you can do it this way. So what is happening over here, I'm multiplying the base with the power function. So if my power function was 2 into 3, this is what I'm doing. So I am having a base over here, assuming this is the base B and this is E. Then what I'm doing over here is I'm multiplying B with the power function. With the power function, why with the power function? I am just reducing this one number. So if I replace this whole thing, I can say power of 2 into 3, which was previously, when it was first called, it was power into 2 of 4, right? Every time I'm going to just multiply the base with the power reduced by 1, power reduced by 1, power reduced by 1, power reduced by 1 and so on, and ultimately I'm going to return 1 if it is less than 0. This is exactly what I'm doing, right? And this is what is happening over here. I'm multiplying the power, I'm multiplying the number with the power of the number with one less exponent, right? I'm going to run this again for you. Let's see if we are done. We are done with this. Let's see the result of this. So it's 2, it's 3, 2 to the power 3 is 8, 3 to the power 3 is 27, and it's working fine for us. What I would like you guys to do is try to debug it like what I did for you using a tree structure, right? Try to do it using a tree structure for what I did for you, and it's going to make a lot of sense for you how it is working, and it will make you understand this concept much further. What I want to do is I want to move further and show you a little bit more complex example of recursion and then trying to solve that, right? So let's start with this. So try to pause the video and guess the next number. What do you think will be the next number in this series? So 0, 1, 1, 2, 3, 5, 8. What do you think will be the next number? It's 13, right? How would I know this is 13? I am getting next number by adding the previous two numbers. Very simple. So if I want to get this number, I'm just adding these two numbers. So 0 into 1, 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. Next number was 13. 5 plus 8 is 13. And next number I know is 21 because I will multiply 13 with 8, right? This is how you do it. This is how you do it, right? This is a series. This is a special series in mathematics. I'm sure you already know this series. So if I wanted to index these numbers, what I do is I will index 0 with 0 index, 1 with 1 index, 1 with 2 index, and all these numbers like this. So these are the indices for this number. And if I wanted to formulate this series, if I want to say I want to formulate this, is there a formula for this? Can I do that in a formulation form? Yes, there is a formula to find the next number or any number in this series, right? So the formula is, if I want to find a specific number in this series, this is the formula: x of n minus 1 plus x of n minus 2. Very simple. And let's solve this with a number, right? I want to find the fifth number in this series. Fifth number in this series. Let's see if I can find that. Since I want to find the fifth number in this series, n is equal to 5. I want to find the fifth number in this series, which happens to be 5. It's a coincidence, but you can do it for 6 also. So let's do it for 5. I will replace all the n's by 5. So x of 5, I want to find x of 5. The number which is at fifth location in this number, x of 5, right? I want to find what that number is. So I will do x of 5 minus 1 in the formula plus x of 5 minus 2. X of 5 minus 1 will become x of 4. 5 minus 2 becomes x of 3. What is x of 4? X of 4 is the number at fourth location, which is 3. What is x of 3? X of 3 is the number at third location, which is 2. 3 plus 2 is 5. And we got this number in fifth location. Similarly, you can do it with 6. So 6 minus 1 is 5. So 6 minus 1 is 5, so which is x of 5. X of 5 is what? 5, right? And then 6 minus 2 is 4, right? What is at x4? x4 is 3. So 5 plus 3 will become 8, which is the number at location number 6. This is how we find it. This series is called a Fibonacci series. Fibonacci series. It was put on the name of the scientist who discovered this series, Leonardo Fibonacci. He was an Italian mathematician, and he came up with this formula which we can use to get any number in this series, any number in this series. But what's so important about this series? This series is pretty important, and you will find this pattern everywhere in your life. For example, if you want to convert miles to kilometers, you can see that Fibonacci series can help you do that, right? Fibonacci series is used extensively in computers, especially in search techniques, and you will see when you will learn data structures and algorithms, you will see that Fibonacci series can be used in search techniques in computers. Then audio and video compressions, they use Fibonacci series to do that. Encryption techniques and security, they use Fibonacci series a lot. And there are some other mathematical algorithms that use Fibonacci series as well. Some natural phenomena like pineapple cells, some of the pineapple cells, they contains Fibonacci numbers like 3, 5, 2, 1. Human organs, they contains like this. I mean, you can find them everywhere. For example, we have 2 ears, so 2 is a Fibonacci number. 1 nose, 1 is a Fibonacci number, and so on, right? So you can find patterns everywhere, and it's a very interesting research. If you want to do, just search online about Fibonacci application. It's pretty interesting. You will see that it's pretty interesting. You'll find these patterns here and there. So this is Fibonacci series, and these are some application of Fibonacci series. What we're gonna do is we're gonna write Fibonacci series using recursion. We can find a code of Fibonacci series without recursion as well, and you can compare it with this code, and you will see that this code is much more optimized than the code written without recursion. So I'm not gonna see this code, I'm gonna write this code for you so that we can both understand what's going on over here, right? So I'm gonna replace this, I'm gonna delete all of this, and what I want to do is I want to maybe take a number from the user, and I want to return the number at that specific index. So what I want to basically do is I want to get, in fact instead of doing that, what I can do is I can write a program that can return us some number of Fibonacci numbers in the series. So for example, if I enter 5, it will return me first Fibonacci numbers. If I say 8, it will return me first 8 Fibonacci numbers. Stuff like this, something like this. We can do it this way, we can do it any way we like, right? We can do a number at, for example, I want to get a number at index 5, and it will return me that Fibonacci number. We can do stuff like that as well. The beauty of this is the function itself will not change. Only the main function, how you are calling that function, will change. So what we can do is we can start with entering an index, giving an index to the function, and that function will return us the Fibonacci number, just like what we did over here. So I want to know what is the number at 5th index, for example, and it should return us 5, right? So let's write a code to do something like this, right? Okay, so first we want to get a number from the user. So user, or I'll call it index, for example, and we'll ask user to enter the index, and user will give us the index, and I'm going to use this index, pass it to a function, maybe Fibonacci or whatever, and that will return us the number at that specific index, right, that specific position. So let's start writing Fibonacci function. So I'm going to call it fib to make it simple. You can write Fibonacci complete if you want, and I'm going to pass it an index. So I'm going to say int index, and we go from here. So we should first of all have a break statement. We should have a break statement, and let's see what that break statement can be. If you see here, let me go like this. If you see here, our break statement can be 0 and 1, right? They can be our break statements. Why? Because we are not going into negative, first thing. So if user is specifying us -1. We don't want that. We want user to enter positive integers. And another break statement can be that if user enters 0, then we are going to return 0, because at index 0 we have value 0, at index 1 we have value 1. So these can serve us pretty well as a break statement. So let's go and do that. If our index is equal to 0, for example, and also let's do it for 1 as well. So you can use two separate statements if you want. I'm doing it in one if statement, and also index is equal to 1, then return us that number, right? Return us that index. Oops. Return us that index. This is what we are doing, right? So if it's 0, 0th index, user is entering 0th index, return 0. If user is entering 1, return 1. Very simple. These can be our break statement. Otherwise we will stay in this loop. We don't want to be in loop, as we know in recursion. We need to break it somewhere, and we have put our break statements like this. So this is what we have. If the number is not 0 or 1, what we can do is we can just make a call to our function to itself. So what is the formula? Formula is Fibonacci of, or the index of n-1 plus index of n-2, right? And this is what we're going to do. So we're going to do fib of n-1, which is index -1, plus fib of index -2. We know this, and we are going to return this as well. We know this is the formula. So index of n-1 and index of n-2, and we did fib of index -1, fib of index -2, right? This is what we did, and that's it. That's how you're going to write a Fibonacci. It looked very complex when we started, but these are the only 3 lines of code you're going to write, not more than that. And we're going to call this. So cout number at index is, we're going to call this function and pass an index to it and do endl, and that's it. So let's see what we have. Let's pass 5, and it is returning us 5. That's what we have over here, right? Let's pass maybe 6. Oops. Let's pass 6, and it's returning us 8, right? This is what we have, 8, right? So this is how you code Fibonacci series using recursion. We are using recursion here and here, and it's calling itself, right? Let's debug this. Let's debug this so that you better understand what's going on. I have written this function here for you, and it's doing something else, but it's very similar. You can generate some number of Fibonacci numbers from the series. What I have done is I've simply passed an index and done something. So we are not going to the main function. We are going to work on this, and let's see what happens. So let's do maybe with Fibonacci of 5, since we are using fib of 5, right? Okay, so let's say our number is 5. User entered, for example, 5 here, so we have 5. So I'm going to use f for function instead of writing Fibonacci. So f of 5, what happens over here is 5 is equal to 0. It's not. Or 5 is equal to 1. No. So this will not work, right? This statement will not work. It will go here. So it will call, it will make 2 Fibonacci calls. So one for n-1 and one for n-2. This is what we wrote, right? This is the code we wrote. So it's going to make 2 calls. So it will make a call for Fibonacci of, let's call it f of 5 minus 1, which is 4, and it's going to call f of 5 minus 2, which is 3, right? Like this. So as soon as your compiler sees something like this, it will go and call itself, which is for f of 4, right? So when it goes up now, it will now have 4 over here, right? It will have a 4 over here. 4 is equal to 0? No. 4 is equal to 1? No. It will not run. It will come here again. What it does is, it will see here, and it will do fib of 4 minus 1, which is 3, and it will do a fib of 4 minus 2, or f of is fine. F of 4 minus 2 is 2, right? And it will have something like this. Now when compiler sees this first one, which is this one, it will go up again. So what it will do is it will now pass 3 over here, right? So 3 is equal to 0 or 1. No, this will not run. It will go to else again, and it will do fib of, it will do something like this. It will do fib of, or I'll do f of 3 minus 1 is 2, and it will do f of 3 minus 2, which is 1, fib of 1. When it sees f of 2, which is this one, it will go up again. It will go up again with now parameter having 2. 2 is not equal to 0 or 1, so it will come over here again. What it will do is it will do f of 2 minus 1 is 1, and f of 2 minus 2 is 0, so it will do f of 0. Now it will run this one, it will see the first one, and it will take it up again. So it will go with parameter 1, since we have 1 over here. 1 is now equal to 1, right? So it will return the number. So this will return now as the number. What is the number? Number is 1, right? So it will return as 1. So this section of the code is now complete, which is returning us 1. Now it will go to this section, right? F of 0, which is this part. So it will go up with 0 now. 0 is equal to 0, yes, so it will return number. Number is what? Number is 0. So it will return 0 to us. So this branch will now close with 0. And what we have to do, since we have both the numbers now, so this is also done, this is also done, we just have to add them, right? So we'll add them and we'll get a result 1. So this branch is now complete and we get result 1, right? Now, so for a fib of 3, one of the branches is complete, which gave us 1. So for fib of 3, this branch is complete, but this branch is not complete, right? Which is this branch, this side. So fib of 1, we know fib of 1, we already calculated fib of 1. Fib of 1 is 1, right? So now we have numbers 1 plus 1, which is both of the numbers we have now. 1 plus 1 is equal to 2, which means that fib of 3 is now returning us 2. So for fib of 3, this branch is also complete. So for fib of 4, this left side branch, which was fib of 3, is complete now, and we are still to calculate fib of 2. What was fib of 2? We already calculated fib of 2, which was 1, right? So it was 1. Now we have 1 over here, and 2 plus 1 will be 3. So fib of 4 will return us 3 over here, right? Now for fib of 5, this side is complete, which is fib of 4, so it returns us this. Fib of 3 is still to be calculated, still to be completed, right? And we already know fib of 3 was 2, so fib of 3 will return us 2, although this will have something exactly similar. It will make a tree like this, but I'm not going to make a tree. We already know that fib of 3 is 2, so fib of 3 will return us 2. 3 plus 2, so we have fib of 5, 3 plus 2 is going to return us 5, right? So fib of 5 is going to be 5. This is what our result will be, right? And if you see, we have fib of 5 equal to 5. Fib of 5 is equal to 5, right? This is how you run a Fibonacci series using recursion. What I would want you guys to do is find a code for Fibonacci without recursion. Just do something like this. Go to Google, type Fibonacci code without recursion, and it will give you a code. It is not a complex code again, but it is 7-8 lines of code, which we have written over here in 3 lines of code using recursion. So you can see the difference between writing the code. And this is how Fibonacci works. This is how you can optimize your code using recursion. You can find a lot of examples of recursion online. Try to see what other examples of recursion are there. For example, there is a game called Tower of Hanoi. Tower of Hanoi, it spells like this, Tower of Hanoi. This is a game that I'm sure you already know about this game. This game can also be solved using using recursion, right? Using recursion. So try to code Tower of Hanoi yourself and see if you can play that game. You can create that game and play that game. And if you can do that, then it means that recursion, you are good to go with recursion. You know the concepts behind recursion. So this is it for today. I'm not gonna bring another topic now because I believe recursion itself is a major topic and it requires a lot of attention from students. So I'm gonna stop here. I have picked 3-4 different programs for you to give you some understanding of recursion. I'm not gonna bring any more right now. I want you guys to explore it yourself, and if you have any questions, please get back to me, let me know, and we can talk about your questions. This week we are going to have a lab session, and in lab session I'm going to give you an exercise on recursion. All right, so I expect you guys to understand recursion, code some programs for recursion, do it yourself. You don't have to follow my code. This is my logic. You can bring your own logic if you want. It is absolutely fine as long as it's producing the right results, the logic is correct. It's absolutely fine, we don't mind that. But as I said, in this week's lab session I'm gonna give you an exercise on recursion. So I want you guys to understand recursion completely. Make sure you have practiced enough so that you can easily solve the task I give you. So try to do this, and if you have any questions, please meet me before the lab session during my office hours, or after the lab session if you don't understand anything. But we are going to have a lab session this week, which is going to be second last lab session, and the last lab session, as I said, we are going to have maybe after a couple of weeks. So that's it from my side. I hope you guys understand this concept. If you don't, you can drop an email to Gurjeet or myself and we will get back to you. Thank you very much. Have a nice day. Bye bye.